Back to this class. So in this class, we are going to start derivative of another function, which is logarithmic function. So where the functions where you have as logarithm functions, it's called logarithmic functions. So first of all, so in calculus, we use Napierian logarithm. Perhaps in your elementary mathematics, you learned about common logarithm, that is logarithm to base 10. So in calculus, we use Napierian logarithm. So that's logarithm to base e. Logarithm to base e. So logarithm to base e. So we write it as ln, ln. Logarithm to base e, which is what? Ln, ln. So when you see this, when you see that is log x base e is the same thing as ln x. So logarithm to base 10 is common logarithm. Logarithm to base e, you know e now, e is a natural number just like pi. So e is also a natural number, we call it Euler's number. So just like pi. So e comes, so when we are dealing with a lot of exponential functions like exponential phenomenon from compound interest to this, they use this particular natural number in finance a lot more than we use it in mathematics itself. So today log to base 10, it's the common logarithm. Log to base e, which is the same thing as ln, it's called Napierian logarithm, and this is what we'll be using in so this is named after a mathematician, John Napier. So logarithm, the history of logarithm in mathematics is one very interesting history. So you can go on and read that. So if y equals to ln x, log x as I would pronounce it, then derivative of the y dx will be equals to 1 over x. If y equals to ln x, the y dx is equals to 1 over x. Just like you have in trigonometric function, if y equals to sine x, the y dx equals cos x. So if y equals to ln x, the y dx equals to 1 over x. So that's the derivative of log x. So how do they arrive at this? It's a lot of observation and consistency. So when we get to where we learn about limits of functions, so we'll come back to this, how we arrive to that, the y dx equals to 1 over x. So from what we have here now, for example, find the y dx if 1. So y equals to, so if y equals to 1 log 2x 2 log 3x plus 4. Find the y dx if y equals 1 log 2x 2 log 3x plus 4. So from the old differential calculus, as we've been solving and learning in the past few weeks, you will have known that when we have a particular function, let's say trigonometric function or exponential function for that matter, so you will realize that when we have sine x, the derivative of sine x is what? Cos x. Just because this x is still what? 1 unit. The x is still 1. But once the x becomes something else, it's more than x. When we have sine 2x, sine x squared, sine square root of x, so then it becomes function of another function. So when it is just ordinary ln x, that's ordinary function ln x. The derivative of ln x is cos 1 over x. But when the angle in this is the argument, in sine it's the angle. So when the argument of that logarithm is beyond x raised to power 1, so then it becomes function of another function. So the first question we have ln 2x, that is function of another function. So then remember the formula for function of another function. So that is what we're going to use to differentiate that. So look at this, ln 2x. Logarithm is function on its own. 2x is another polynomial function on its own. So now we use function of another function. So remember function of another function that says that if y equals to f of u such that u is equal to f of x, then the y dx will be equals to, first you differentiate y with respect to u, that will be the y du times the u dx. So then you multiply the two together, that will give you the derivative of y. So in this case now, we have ln 2x. We say let u be equals to what? 2x. So if u is equals to 2x, that implies y will be equals to what? Ln u, right? So then from here now, to find our dy dx, because first you find the y du, so you find the y du first, that is, you differentiate this y with respect to u. The y du will now be equals to, so derivative of y with respect to u, since the y dx, if y is equals to ln x, the y dx is equals to 1 over x. That implies if y is equals to ln u, the y dx should be equals to 1 over u. 1 over u. Also, now the next thing is that you differentiate u with respect to x. From here now, du dx will be equals to, remember, the derivative of polynomial function. So derivative of 2x is equals to what? 2. Equals to 2. Now from here now, the y dx equals the y du, 1 over u, that's the y du, times du dx, 2, which is equals to what? 2 over u. 2 over u, that is 1 over u times u. But remember, don't forget that your u is equals to 2x, but u equals to what? 2x. So that implies the y dx will be equals to 2 all over u, which is what? 2x. From what we have here, 2 cancel 2, that is equals to what? 1 over 1 over x. That's 1 over x. Okay, so the second question is y equals to log 3x plus 4. So find the y dx. So find the y dx if y is equals to this. So then from here, you know this is a function of another function. So then we say let u equals to 3x plus 4. So if u equals to 3x plus 4, that implies y will be equals to what? Log u. Log u. So, and then from here now, to find out the y dx, since we know that the y dx will be equals to the y du times the u dx. So first we'll find the y du. So find the y, differentiate y with respect to u. So the y du will be equals to, so the y du, that is, this will be equals to what? 1 over u. Since we know that the derivative of ln x is equals to 1 over x, that means ln u will be equals to 1 over u. Also, the u dx, differentiate u with respect to x. The u dx will be equals to, so you differentiate this. The derivative of 3x is what? 3. Plus the derivative of 4 is what equals to what? 0. 3 plus 0 is what? 3. So now implies we have the y dx to be equals to the y du. What is our y du? 1 over u. 1 over u times the u dx. That's what's our u dx? 3. And that is equals to what? 3 over u. But remember that your u equals to 3x plus 4. So that substitute that. So implies the y dx will be equals to 3 all over 3x plus 4. So that is the derivative of that. So this is where we're going to stop in this class. So I'll see you in the next class, and that's tomorrow.